Ocean movements, surface currents. In this module, you will learn about surface ocean currents, its types and its circulation in ocean water. Just as air has a circulation pattern, so do oceans. Circulation pattern of oceans depends on ocean currents, which in turn depend on differences in temperature, density, pressure, forces of wind, and gravity. A current is the regular and generally horizontal flow of ocean water in a definite direction. Ocean currents are the most powerful movements as they drive water for thousands of kilometers. They help steer ships and animals in water. There are two types of ocean currents: surface and deep. The surface ocean currents circulate in the upper layers of the ocean, whereas deep ocean currents circulate in the deep ocean. In this module, you will focus on the surface currents and their circulation across the globe. Surface currents are mainly powered by winds. When winds blow over the ocean, it creates friction between the air and the water. This friction helps the wind to drag along the upper thin layer of the ocean. This top layer of the ocean pulls along the next layer. The impact of the frictional force exerted by the air lessens as the depth of the ocean increases. Thus, the wind dies out a few hundred meters below the ocean's surface. In this way, the wind causes surface currents which circulate on the surface of the ocean. Observe the map showing the circulation of surface currents. You might notice that the currents mainly have circular patterns called gyres. But why do these gyres move in a circular pattern? The circular patterns of surface currents are mainly caused by the Earth's rotation and bordering land masses. In the northern hemisphere, the Earth's rotation causes the winds which drive surface currents to deflect towards the right, and in the southern hemisphere, the winds help the surface currents to deflect towards the left. This is called the Coriolis effect. Also, bordering landmasses modify the path of these currents to rotate clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. If you examine the map, you will observe 5 major gyres: 2 in the Pacific Ocean, 2 in the Atlantic Ocean, 1 in the Indian Ocean. In addition to these, there is one major surface current circulating around Antarctica. The surface ocean currents can broadly be classified into 2 types: warm currents and cold currents. These currents help in the exchange of heat between low and high latitudes. Warm currents originate near the equator where the temperatures are high. From here, these currents flow towards the poles where the temperatures are low. These currents carry warm water with the equatorial region to temperate and polar regions and raise the temperatures on land. The Gulf Stream is an example of a warm current that originates at the tip of Florida and flows along the eastern coast of North America and reaches the western coast of Europe. Since it originates from a warm region, its warm water keeps Europe warmer than the other areas at similar latitudes. Cold currents originate near the poles where the temperatures are low. From here, these currents flow towards the temperate and equatorial regions. These cold currents carry cold water and lower the temperatures on land. The Labrador Current is an example of a cold current which originates in the Arctic Ocean. It flows between Labrador and Greenland to the coast of Newfoundland, Nova Scotia and New England. In this module, you have learned An ocean current is the regular and horizontal flow of ocean water in a definite direction and help the transfer of heat from low to high latitudes and vice versa. There are two types of ocean currents, surface and deep. The surface currents circulate in the upper layers of the ocean, whereas the deep ocean currents circulate in the depths of the ocean floor. Surface currents are powered by winds and move in circular patterns called gyres. The surface currents are of two types, warm currents and cold currents. Warm currents flow from the equatorial region towards the poles. Example, the Gulf Stream. Cold currents flow from the poles towards the equator. Example, the Labrador Current.